is Alexandra Colosino, and today I will be talking to you about how to determine the identity of an unknown compound using spectroscopy. The purpose of this experiment was to identify an unknown compound in a contaminated water solution using spectroscopic techniques. These techniques include infrared spectroscopy and nuclear magnetic resonance spectroscopy. The significance of this experiment is that it allows us to identify environmental and health hazards that may result from exposure to the unknown compound. Before I talk to you about how the experiment was performed, I would like to give a brief overview of IR and NMR. Infrared spectroscopy allows us to determine the types of functional groups present in each compound. Each functional group has a different range of absorption, which is pictured on the table here. For example, 1,2-dichloroethane contains a CCl functional group whose range of absorption is from 850 to 600 inverse centimeters. In addition, the compound contains a CH functional group whose absorption range is 3,010 to 2,800 inverse centimeters. Nuclear magnetic resonance spectroscopy allows us to determine how many different types of hydrogen atoms are present in a compound, as well as the relative number of each. This then tells us the number of peaks in an NMR spectra and the size of each peak. For example, methanol has two different types of hydrogen atoms, 3 of one and 1 of the other. This gives us a ratio of 3 to 1. In contrast, the benzene compound contains only one type of hydrogen atom. However, there are 6 of them. This compound has no ratio. Now that I have given a brief overview of IR and NMR, I would like to begin to discuss the experiment and how it was performed. The first step of this experiment was to predict the IR spectra of each possible compound. This was done by looking at each of the compounds and their structures and identifying the functional groups that were present in each. The data was then recorded on the table pictured here. As you can see, the possible molecules are listed down the left side of the table and the functional groups across the top. An X marks the presence of a functional group. The next step was to predict the NMR spectra of each of the possible compounds. This was done by predicting the number of peaks and the ratio of each peak based on the types of hydrogen atoms and the number of each. The data was then put on the table like the one pictured here. Now that we have predicted both the IR and NMR spectra, we are able to test the unknown compound. The first step was to place 2 drops of the unknown compound using a dropper onto a salt plate. 2 salt plates were then placed together and put inside the spectrometer. Infrared radiation then passed through the sample, and the detector was able to plot percent transmittance through the molecule versus the wave number of radiation. Then a spectra was developed, which is pictured on the right. From the spectra, we see that there are 2 absorption peaks from the unknown compound. The first has a value of 3,368.62 inverse centimeters, which corresponds with the OH functional group. The second is 2,884.91 inverse centimeters, which corresponds to the CH single bonded functional group. Next, the NMR spectrometer was used on the unknown compound. A tube with a sample of the unknown compound was placed in the spectrometer between 2 poles of the magnet. Then, radio frequency radiation was passed through the sample. The emission absorbed energy was monitored and another spectra was developed. This spectra shows that there are 3 different peaks with a ratio of 1 to 1 to 6. Now that we have tested the unknown compound using IR and NMR, we are able to compare the results to the predicted IR and NMR tables developed at the beginning of the experiment. As you recall, the IR spectra showed that an OH and a CH single-bonded functional group were present in the spectra. This allows us to narrow our focus to 4 possible compounds: methanol, ethanol, T-butanol, and 2-propanol. Now we can look at the NMR spectra once again, and we see that there are 3 peaks with a ratio of 1 to 1 to 6. This allows us to identify our unknown compound as 2-propanol. Now that we have identified the unknown compound as 2-propanol, it is important to discuss both the environmental and health hazards that may result from exposure to 2-propanol. According to the International Program on Chemical Safety, 2-propanol is transported into soil and water. 2-propanol is readily biodegradable and completely miscible in water. This means it is not likely to accumulate in the environment. Not many studies have been done on repeated exposure of 2-propanol to animals, but it is likely that the effects are similar to those experienced by humans. There are numerous health hazards that result from exposure to 2-propanol. Types of exposure include ingestion, inhalation, eyes, and skin. The Center for Disease Control and Prevention reports that side effects include cough, vomiting, and unconsciousness, among many others. From this presentation, I hope that each of you are able to recognize how important IR and NMR can be in identifying unknown compounds. It is a relatively simple process that provides us with a great deal of knowledge. Not only are we able to identify an unknown compound, but we are also able to recognize and educate others on the environmental and health